Mitochondrial DNA disorders. Remember, cellular respiration or oxidative phosphorylation occurs in the mitochondria using a series of enzymes that convert carbs, proteins, and fats into ATP. As we previously discussed, most disorders of mitochondrial function are autosomal recessive, although some can be autosomal dominant or X-linked. In addition, the mitochondria has its own DNA, which is only maternally inherited. Mitochondrial disorders can be extremely varied in presentation. The mantra for mitochondrial disease is any symptom, any tissue, at any age. Frequently affected systems include the neuromuscular system and the cardiovascular system, or really any high-energy system. Diagnosis can be tricky, and treatment for most mitochondrial disorders don't have good evidence. There are sets of symptoms or phenotypes that have names in which certain problems typically go together. However, these phenotypes can be caused by different gene mutations, and because of the variability in mitochondrial disease, the same gene mutation can cause different phenotypes. Let's start with Kearns-Sayre and chronic progressive external ophthalmoplegia, or CPEO. These disorders are classified by the following triad: 1. Ptosis, 2. Ophthalmoplegia, and 3. Ragged red fiber myopathy, which refers to how the muscle looks on biopsy and is a common finding in mitochondrial disorders. In Kearns-Sayre syndrome, you see these symptoms in addition to cardiomyopathy, diabetes mellitus, cerebellar ataxia, and deafness. There are several mitochondrial syndromes that are common and whose name speaks for themselves. There's myoclonic epilepsy and ragged red fiber disease, often abbreviated as MERRF or MRF. Then there is MELAS, MELAS, which stands for mitochondrial encephalopathy, lactic acidosis, and stroke-like episodes. In MELAS, other symptoms of mitochondrial disorders can occur, including deafness, cardiomyopathy, diabetes, and cerebellar ataxia. Note that the ataxia frequently occurs before the strokes do. Finally, there's Leigh syndrome, which is characterized by severe neurologic abnormalities, respiratory dysfunction, and a characteristic brain MRI with bilateral hyperintense signals on T2 in the basal ganglia, cerebellum, and brainstem.